I've had a few messages on my recent videos asking if I can do a further maths or higher GCSE paper. So in today's video, as you can see behind me, I am going to attempt to do the GCSE further maths paper that I did back in 2018 for my GCSE to see how I get on. As I've gone through, I've explained all of my answers and shown all the workings as well, so you can use it as a really useful revision source with the upcoming exams. As always, if you have any questions, let me know down below in the comments and I will get back to you as soon as possible. But apart from that, I hope you enjoy, and thank you for watching. So question 1 looks like it's about differentiation. All we have to do is differentiate the equation up here. Now I'm going to rewrite it slightly and just bring the fraction out into the front as a half and a quarter. For those of you that don't know, when we differentiate, you want to bring the power down and multiply it, and then decrease the power by 1. So 6 multiplied by a half is 3, so it's going to be 3x to the 5 plus x cubed. And that is going to be our first answer. So question 2, we have point P, Q and R, where Q is the midpoint of PR. I'm just going to do a rough sketch, which I would recommend you always do if you have the space to, and it will just help us visualize it a little bit more. So I'm going to do the x values at the top and the y values underneath. Now using this, we can kind of analyze the steps that they've taken between P and Q and R. So straight away, to get from P all the way to R is an increase of 18. Which means that Q, because it's in the middle, it must be split into 9 and 9. So that means that A must equal minus 3. Using the same idea, you notice to get from Q to R, they have taken away 6, which means to get from P to Q, they've also taken away 6. So B must equal 4 plus 6, which equals 10. And that is our final answer for that. Next, we are multiplying two matrices together. So we have 2, 4, 3, minus 1, and minus 2, 6, 2, and 1. If you haven't learned how to do matrix multiplication and you're doing A-level maths, I highly recommend learning it because it's very useful. It's a bit of a weird one if you haven't seen it. So we need to do 2 multiplied by minus 2, add 4 multiplied by 2. Then for the second one in the top right, we're going to have 2 multiplied by 6, add 4 multiplied by 1. 3 times minus 2, add 2 times minus 1. And then finally 3 times 6, add 1 lots of minus 1. And if we simplify all of that down, our final answer is going to be 4, 16, minus 8, and 17. Question 4, P equals 4x, Q equals 7x. P increases by 25%. So if P equals 4x, 25% of 4x is just x. So the new P is going to be 5x, and Q equals 7x, which decreases by 40%. So 40% of 7x is going to be 2.8x, which means that the new Q is going to be 7x minus 2.8x, which is going to be 4.2x. Now P is 28 greater than Q, so 5x is going to be 28 plus 4.2x. Which ultimately means 0.8x is equal to 28. If we divide that by 4, we can get 0.2x equals 7, so x is equal to 35. In the expansion and simplification of this double bracket, the coefficient of x squared is equal to the coefficient of x. K is a constant, work out k. Okay, well straight away, just by expanding the bracket out, we know that we're going to have x cubed plus 5x squared plus kx, and then if we go underneath with the next 3, minus 3x squared minus 15x minus 3k. We know that the x squared coefficient is equal to the coefficient of x. So we have 5x squared, we also have 3x squared. So if we take them away, we're going to be left with 2x squared. So the coefficient of x squared is 2. We can use that to work out the coefficient of x. So we know that the coefficient of x is going to come from the k and the minus 15. In other words, k minus 15 is equal to 2, so k must be equal to 17. A circle equation where we have multiple choice. So a centre of minus 1, 2. As a coordinate, the centre is always the opposite of what it looks like in the equation. So it'll be x plus 1 squared plus y minus 2 squared, and then you'd square the radius, so it'd be 25. which correlates to this third one here, so it'll be that one. Question 7. It looks like we're going to have to use some form of circle theorems. Now straight away, the first circle theorem that pops out to me is that we know that the angle at the centre is double the angle at the circumference. So for this, we know that it must be 360 minus x plus 75 is equal to 2 times the angle at the circumference, which is going to be 2 lots of 2x. Now this will correlate to 285 minus x equals 4x. So 5x is equal to 285, which means x equals 57 degrees. And that is your final answer. So this one doesn't look too bad, just kind of like higher GCSE level. We just need to expand some double brackets with surds. So 1 multiplied by 4 is 4, minus root 5, plus 8 root 5, minus 10. So if we collect all the like terms, we're going to have minus 6 and plus 7 root 5. And they are both integers, the a and the b, so that works. On to question number 9. F of x equals 14 minus x squared for all real values of x. We must solve this. So first of all, we need to replace x with 2x. So that's going to be 14 minus 2x all squared equals 5, and we need to work it out for x. So rewriting this is going to be minus 4x squared equals 5. If we take the 4x across to the right and the 5 back across to the left, we're going to be left with 4x squared equals 9. So x squared equals 9 over 4. And this means that x equals plus or minus 3 over 2. It is important you remember the plus or the minus, or you will not get full marks. Rearrange this to make x the subject. Now this is a tricky one, but first of all, we don't like fractions when we're changing the subject, so I'm just going to multiply them all up. So 1 equals 4xy minus 3xy over y. Next I can see I can cancel those two, so rewriting that, we're going to have this. Now the problem we have here is we have x in 2 different forms on the same side. So what we can actually just do is factorise, so we can take an x out, leaving us with this, and then if we divide by the bracket, x is going to be 1 over 4y minus 3, and that's going to be our final answer. A curve has equation of this. At point P on the curve, the tangent is parallel to the line of this. Now for those of you that don't know, when we differentiate, it gives us a function for the gradient of a curve. So if we work out dy by dx, that's going to be, again, bring the 2 down to the front, so it's going to be 4x plus 3. And because it has to be parallel, this line has a gradient of minus 5. So we know that this must equal minus 5. All we have to do now is solve that value. So 4x equals minus 8, so x equals minus 2. That's our x value. And then to work out the corresponding y value, we substitute it into the curve up here. So y equals 2 lots of minus 2 squared is 4, plus 3 lots of minus 2, minus 9 is going to be 8, minus 6, minus 9, which is minus 7. And that is our final value there. In the diagram, A is the point 15, 0, B lies on the y-axis. Tan of theta equals 5 over 3. That's going to be important here. Now tan of an angle is opposite over the adjacent. As you can see here, we have a right angle triangle. If the angle is here, that means that this is going to be the opposite, and this is going to be the adjacent. We know that this is currently equal to 5 over 3, but looking at the diagram, because we know the coordinate of A, this value is actually 15. So that means the bottom of the fraction must be 15. We've multiplied by 5 to get there, so we have to do the same on the top, which makes that one 25. So the opposite, or the height of this, is 25. We can use that to know that the coordinate of B is 0, 25, and that solves our y-intercept of the equation of the line BC. Now all we have to do is work out the gradient. Now the gradient of BC is going to be the negative reciprocal of the gradient of AB, because they are perpendicular. And because we have 2 coordinates of AB, we can work out the gradient of it. So we're going to use the 2 coordinates of 0, 25 and 15, 0. And we can work out the gradient by doing y2 minus y1, which is 25 take away 0 over 0 minus 15, which is going to be 25 over minus 15, or minus 5 over 3. So the negative reciprocal of that is going to be 3 over 5. So our final answer is y equals 3 over 5x plus 25, because the y-intercept we worked out earlier. Solve the simultaneous equations, do not use trial and improvement. So basically do proper workings and think of a method that works. We get 6 marks for this, which is very rewarding. Straight away, I notice we can do, if we rearrange this one, we can write it as 2 over x. And then we have two equations that we can put equal to each other because they both equal y. So 2 over x equals 3x plus 5. Again, we don't like the fractions, so we're going to multiply by x, leaving us with 3x squared plus 5x. If we bring everything onto one side, we can solve it like a quadratic. Now factorising this, we can have 3x in the front of this bracket and x in the front of this one. And to get 2, you can only multiply 1 and 2, which makes our life very easy. Plus 2 this side, minus 1 that side. So x must be a third, or x must be minus 2. And again, to work out the corresponding y values, on this side y must equal minus 1, and on this side y must equal 6. And here are our 4 solutions, or 2 pairs of solutions. Work out the value of this. This is just like some hard indices laws that you could potentially see at GCSE in the normal spec. So 3 to the power of a half is root 3, and 3 to the power of 3 over 2 is root 3 cubed, and we have to square all of that. Now root 3 cubed is the same as root 3 times root 3 times root 3. This is just going to be 3 root 3. So I'm going to rewrite this as root 3 plus 3 root 3 squared, which simplifies to 4 root 3 squared, which is going to be equal to 16 times by 3, so our answer is 48. Here is the graph of y equals 3x minus x squared from minus 1 to 4. The question will be on the next page. By drawing a suitable linear graph on the grid, work out approximate solutions to this equation here. It's very difficult to spot these type of questions, and they're not easy to work out either. So we need to remember this one, x squared minus 4x plus 2. X squared minus 4x plus 2 equals 0. Now we need to cleverly choose something that goes alongside this so that when we rearrange it, it gives us this equation here. We currently have this equation. If we were to let y also equal 2 minus x, you will see when we put them together, we're going to have 3x minus x squared equals 2 minus x. And if we rearrange this and get it all on the right hand side, for example, we're going to have x squared minus 4x plus 2, and that is now equal to 0, which is the equation we're after. So we need to draw the linear graph of 2 minus x onto here. So our y-intercept is 2, and it's going down with a gradient of negative 1, so it's going to go through just like that. And the points at which they intersect are going to be our solutions. So this value and this value. So if you bring them up, you can see we've got 0.6 and 3.4. And they are actually our 2 solutions that we need. Y equals f of x is a cubic curve with a maximum and a minimum stationary point. So again, remember that once we've differentiated, that is a gradient function that we can use. So if we were to set this equal to 0 and solve it, it will give us where the gradient is 0, and that's where the turning points are. So if we factorise this up, we're going to get plus 3 and negative 1, which correlates to x equals 1 and x equals minus 3. And because it's a positive cubic, because as you can see when it's differentiated, it is not negative basically on the x squared coefficient, it's going to look something along the lines of this, which means that the first coordinate we come across, which must be minus 3, and this one must be the 1, that this one must go with the maximum value, and we know the y maximum value is 13, and the 1 must go with the 2 and a third value there. We also know that 0, 4 is a point on the curve, so that would be our y-intercept here. Now it doesn't matter too much about the scale, as long as you get the coordinates in the right order, then they don't really mind in the mark scheme. Use the factor theorem to show that x minus 2 is a factor of this. This is a given mark. You should go into an exam looking at this type of question and know exactly what to do. If this bracket is a factor, it means that the value of x equals 2 when subbed in must make the equation 0. So 2 cubed plus 8 times 2 squared plus 5 lots of 2 minus 50 should equal 0, but obviously we have to work that out. So 8 plus 32 plus 10 minus 50, that equals 40. Plus 10 we get 50, and then 50 minus 50 equals 0, so therefore it's a factor. Hence, factorise fully this value here. So we've just worked out that that is a factor, so we can use the bracket. Because the last value is a minus 50, then the value that goes here should be a plus 25, because if you think about expanding out a bracket, the only way to get the 50 would be to multiply those two values. And in the middle we have a kx. So we have to multiply two things together so that they multiply to make 25, but add to make that k in the middle. Now 25 can either be 5 and 5 or 1 and 25. However, looking at the values that we have to create, such as the 8x squared and the plus 5x, it's not going to work with the 1 and 25. And I'll leave that up to you to give it a go if you want to. But the 5 and the 5 are going to work, and they add together to make 10. So it's going to be x minus 2, x squared, add 10x, add 25, which we can then factorise down to x plus 5 all squared, just like that. And that is fully factorised. It looks like here we just have some complicated completing the square. Again, if you're working towards a level 8 or a 9 at GCSE, you'll probably be quite familiar with this anyway. So whenever we have a 2 at the front, or a 3 in that case, we want to get rid of the 2 first. So you factorise the entire equation. So x squared minus 8x plus 6.5. I'm just going to keep it in a decimal form because it's a little bit easier at the end. We then complete the square on the whole middle bit. So minus 16, add that 6.5 again and close the bracket. Once we got to this point, just want to simplify those end terms. So we have 2 bracket x minus 4 all squared. Minus 16 add 6.5 is going to be minus 9.5. And then finally we want to multiply the minus 9.5 out of the big bracket, leaving us with minus 19. And that is going to be our final answer. Again, these are all integers, and the 2, the 4, and the 19 are all integers as well. And then on to our final question, question 20. Again, if you're doing a high level at normal GCSE, then this shouldn't be a problem because this is just the sine rule. So as you can see, we have a complete pair of angles and sides, so we can use the sine rule for this one. So x over sine 45 equals 6 root 2 over sine 60. The tricky part about this is a non-calculator paper, so you need to know your exact trig values as well. If you haven't seen previous videos, I have shown you tricks on how to work out those. If we need the 45, sine 45 is going to be the opposite over the hypotenuse, so sine 45 is 1 over root 2. And then when we have the angle of 60, we can use another triangle where that is 60, that is 1, that is 2, and that is root 3. So sine of 60 is going to be, again, the opposite over the hypotenuse, so it's root 3 over 2. So sine 60 equals root 3 over 2. Comment down below if you haven't seen that before, and I'm more than happy to explain how it works if you want to. But now we can just use these and substitute them in. So 6 root 2 divided by root 3 over 2 multiplied by 1 over root 2, because we're multiplying this sine 45 over to this side. Now when we divide a fraction, we're actually just going to multiply it and flip it over. So 2 over root 3 instead. That's going to leave us with 12 root 2 over root 6, which we can simplify to 12 over root 3. And if we rationalise the denominator on that, you'll find we get 4 root 3 as a final solution. So it is 4 root 3 centimetres. And that is the end of the paper. So thank you very much for watching, and I hope that helped. Any questions that you aren't too sure on, let me know in the comments down below, and I will get back to you as soon as possible.